So the previous keynote speaker said we need engineering companies to be included. Here we are. I come from Elea IC. We are an engineering design company specialized in a wider range of design projects, from tunneling, high-rise, actually like highways and so on. What I'll be talking today is consistent and standard model content, which is basically just an extrapolation of the previous talk. And I would start with a question for all of you. Raise of hands, all of you who think that you know something about BIM, that you work with BIM, that you use it. Raise of hands. Okay? So the rest of you want to learn. Okay, cool. That's good. I would say for myself that I know, let's say, 2.5 words of BIM. I know about buildings, I know about models, but I'm still quite learning about information. Why is information important? First of all, we have to figure out and we have to realize that there are a lot of issues with information, with big information management in the world now. We're producing more and more information. 90% of all information was produced in the last 2 years. 90% of all information and data on the internet was produced in the last year. And by 2025, 30% of all data everywhere will be streamed real time. That means we'll have to figure out how to deal with that data. And the other industries are basically doing that. What we have to do in the construction industry is catch up. So what are we going to do? What are the challenges? What are the needs? First of all, we have to figure out how are we going to improve our data management. Then we have to figure out how are we going to use this consistent data and form information out of it. And then how we're going to use that information and transform it into knowledge that will help us build better projects, have better project management, and at the very end, raise the entire industry a level up. So this is, the entire presentation is going to be basically how to use data, how to use consistent data inside of BIM models. So, one of the solutions is to use BIM, because we know it's building information modeling, which is a process, and a lot of the previous speakers said that we can use BIM in variety of areas. I agree with that, but we do need some, let's say, requirements before we start using that. We need to know how to use software that we have actually on the market. We have to know how to manage that data. We have to know how to form new workflows around this new process and how the information flows through this process. Then we actually have to know exactly what's in our models. If we don't know that, we don't know anything. That it's just building modeling. It's not building information modeling. We have to figure out what data has to go inside of the models, that it's meaningful, that it's intelligent. And then we have to figure out how we're going to process all that data, all that information inside of our models and transform into knowledge. So that's the main workflow, is to get from the real life into actually the knowledge through these BIM models and BIM processes. So there are a couple of requirements. First of all, we haven't talked about this much in this conference, but we have to realize that employers, so that means investors, owners, play a huge role in how we can actually use BIM. They have to define their vision. They have to have the knowledge of BIM. They have to educate themselves if they want to actually have useful results from their projects that use BIM. So they have to define their BIM requirements from their goals. They have to define how are they going to use them, how is BIM going to be used, and what are the final results. And they have to actually create a document that's an AIR, that means Employer Information Requirement, that defines exactly the use cases, the requirements, and actually what they want, what the employer wants to do with BIM. The companies then need to, in reply, make their own document. This is the BIM execution plan that I'm going to talk about later. They have to accept and use BIM. They have to improve workflows. They have to proficiently implement BIM, which is a really hard task for all these use cases. And they have to improve on different fields. So, what actually consists of a, let's say, standard BIM execution plan? Basically, you have to define all of the models that have to go into the workflow. Who's going to do them? What's going to be included into them? They have to define all the workflows that the project is going to follow. Then, this is really difficult, they had to classify everything in the models. If you don't have a classification, we can't use those models. We don't know what's in them. Then we have to define how developed those models are, what information goes into them, exactly what information, because if we don't have information, we just have 3D models. And then we have to define exactly for the element types or the element objects inside the required properties. So that means the names, the values, and it has to be consistent over all the models. And then we have to figure out how this information is going to flow. And that all is defined in the BIM execution plan or a similar document that leads the project. So how we approached it is actually on one side simple, on the other complex. I'm going to simplify it here. The employer defined their requirements, and they have certain, let's say, properties that they want to include, some information they want to include in the models. From there on, we develop our own information required for our workflows so that we can actually produce the results that they want. And we combine those two, and we basically feed all of the data, the entire framework, into the SQL database. From there on, since we have a framework in the database, we can feed it into the authoring environment. So that means either Revit, Civil 3D, Archicad, name it. You can basically just program the interface. And then we also feed it into analysis tools. And then we connect those two, the authoring environment, so the BIM models, and the analysis tools that produce results. And the results are basically knowledge. So the entire workflow flows from the information definition through the framework definition and then into the actual tools that produce results. Since it's an iterative process, we're always, every single project is fed back into our knowledge. So that means that the next project that we create is going to include all the knowledge from the previous projects. Okay, why am I talking about this? It's simple, right? Like concrete is concrete. Well, not quite. On one of our projects, this is Karavanka Tunnel that we did a couple of years ago and it's still ongoing, as Slovenes know. We had a couple of companies that created different models. And we said, okay, let's have a quality of concrete included in all the concrete elements. And we figured out, okay, everybody knows how to define the properties. Unfortunately, that's not true. Everybody in their own companies has their own idea how they want to define the values. So is it slash? Is it backslash? Is it a dash? And that becomes a problem. If you don't have consistent data, you can't really feed all this data into workflows, into rules, because the rules break. They don't figure out what's going on. So if I say that we have different data, if we make it consistent, then we can feed the design data, the monitoring data, and the construction data into our models, into our tools, and after some work done on that data, on that information, we have knowledge. And knowledge means we have histograms, we have time schedules, we have construction animations, visualizations, and at the very end, we have quality control. This is one important thing for BIM, that the previous methodology, so the 2D methodology, does not cover. We have quality control over what we're doing. We know exactly how the information is going and what the results are. And you're probably asking yourselves, okay, that sounds very nice and clean, but can you back it up? Actually, we had a project last year. It was a tunnel interchange in Sydney. It was a very, very intense project. There were 2 construction sites. It included 20 road tunnels, 6 access tunnels, 6 ventilation tunnels, and basically a combined length of more than 19 kilometers. Basically, we called it a spaghetti. The problem was the submission time was really, really short. It was 3 months. And what we had to do, we had to optimize the design. We got the design from other designers and we had to figure out which one is the best. We had to figure out how to optimize the construction and the excavation of those tunnels. And at the very end, we had to figure out how to optimize the overall pricing and the cost, because it had to be submitted in the actual cost, not just an approximation. And this was our goal. And what we did is actually, for us, it was quite complex. So we first said, okay, let's figure out how the Sydney people are doing those things, how they are modeling and actually how they are constructing their tunnels, how things are done in Australia. We studied it, and we figured out some rules. We wrote them down. And then we created some parametric models, some parametric families in Revit, and some scripts in Dynamo that actually feed the data and drive those families. And at the very end, we fed that into some of our tools. We got optimized results. We fed it back to the SQL attribute database, and we fed it back to the changes. The changes came 5 times in 3 months. You can imagine the entire project changed slightly in 3 months for 5 times. We had a huge amount of data, a huge amount of models, and at the very end, we had 18 concurrent, so that means parallel excavations going on in the same time. And we had to optimize that. And the result was something like this. Well, just let me find it. Okay, perfect. So what you can see is basically an animation of excavation and then further on shotcrete on the main screen. Down below is the interesting part. You can see the data flow. You can see the knowledge. You can see how much excavation is coming out each month, each week, each day. How much shotcrete is used with all the norms that they've given us. So how much is being bounced off? That's also included. How many bolts, rock bolts, are we using in our process of constructing this tunnel? How much of the rest of the tunnel equipment are we using? When is it being equipped? When is it being installed? So this is basically the result of 3 months of very hard work of advanced use case implementation of BIM models. So at the very end, this is what the client wants. They want to know how much it's going to cost, how much time is going to need to be constructed, and how they can optimize it. And basically, this is the, basically, this is the thing that we have to do. So, if we have consistent data, if we have consistent information inside our models, we can have advanced BIM use cases that follow certain rules, that follow certain procedures that we define beforehand. And then we can get better results with data analysis. We can actually have benefits both for engineers that can provide this data, that can provide these results, and also for employees. So basically, for the investor. We can have a higher quality of projects because it's optimized. At the very end, we can have more transparency and traceability, which is really a big drawback currently for the construction industry. And at the very end, we have less disparity and lower costs for all our projects if we follow through with our designs and consistent data. So I would argue that we know a lot about buildings, we know a lot about modeling, but we have to figure out how to have consistent data, consistent information, and consistent model content if we want to use advanced use cases. Thank you.